Today's topic is PCB respins due to mechanical enclosure errors can cost you time and money. Today, we're going to discuss the design process and the design tools that reduce these respins. We're putting it all together with real-time mechanical collaboration with SOLIDWORKS PCB. My name is Scott Davis. I'm the product manager here at Hawk Ridge Systems for the SOLIDWORKS PCB products. There are actually two products. One is the full schematic capture circuit board layout package, SOLIDWORKS PCB. Our other product is exclusively for Altium Designer, and that allows Altium to provide the same real-time collaboration with SOLIDWORKS 3D CAD, which I will demonstrate today using SOLIDWORKS PCB. So, like your company, many companies, they're making incredible products, right, that change the way we live today. The beauty of these technological output and the slick design is that it actually masks some of the complexities and the challenges that engineers go through to create these life-changing products. The designs are often driven by mechanical organizations, right? So the PCB usually has to fit in the mechanical enclosure. And then all the design data resides locally in the mechanical assembly. All of the data, including the PCB. Why? Because the PCB is represented by one part number, even though it contains a huge amount of electronic detail. So let's talk about some of the design challenges that companies face today in their current product development process. First is the electromechanical disconnect. Additionally, could be a lack of a modern design flow. Could be using multiple tools, multiple systems, multiple ways to save data and manage data. And then you have that inconsistency of that data management. Where is it? Who owns it? Who manages it? Who has the permissions? And oftentimes, you're wasting time in doing non-role specific tasks, including some additional documentation, file manipulation, file management. We solve these issues today with SOLIDWORKS products. SOLIDWORKS 3D CAD, SOLIDWORKS PCB design, and the overall data management system with SOLIDWORKS PDM. Our design flow, and a typical design flow, is electromechanical collaboration. You have your data management. You have to synchronize your design. You have to manage your supply chain. And then you've got to go through the entire release process of the whole product. What are the challenges for the electromechanical design portion? The outlines are owned by the mechanical engineering team typically. Oftentimes you're doing export DXF files, step files, sending them through email, importing them into your PCB tool, redoing a drawing, or additional investigation into what's really going on with the information that was provided. Another challenge is the mechanical engineer may be defining critical parts, defining the keep outs, but again, this takes more work. It can often be doubled by the mechanical engineer and the electrical engineer. Interference and collision detection. Again, oftentimes today, companies are exporting files, step files, using 3D boundaries, checking them in your current PCB CAD tool. It's fairly manual process. And then how do you track the changes? If you're importing and exporting files, sending them through email, converting them into your PCBA tool, send them back to the mechanical engineer for verification, you often have to have a discussion, accept or not accept the changes, and it's typically, again, it's a manual process. The steps in our process will improve your overall collaboration between electronics and mechanical information. You can define the board outline, the holes, the critical components, keep out and component barriers, case definitions, and you can refine the placement using SOLIDWORKS 3D CAD. This process that we're going to show you today reduces errors, absolutely improves your accuracy because you're working with one set of data. Using one set of data is going to save you time and effort. So let's take a look at the steps in the design workflow and what we can do to improve them and how you might be working through this process today in your own environment. Data management. So how is the electrical data managed today at most companies? Typically, you've got a set of files, output from your CAD tool. They're residing somewhere. They're linked together, put on a project folder. You've got to go search that project folder, manipulate the files, package up zips, and send them to your suppliers for fabrication and assembly. Our solution has built-in version control using the PCB services database and overall product management data files with SOLIDWORKS PDM. SOLIDWORKS PDM then becomes the nucleus for your entire data management system for your products. Your design synchronization. You have a disconnect typically between your ECAD tools. You may have one schematic capture tool. You may have another PCB layout tool. Therefore, you're exporting net lists, you're exporting footprint files, you're synchronizing into your PCB tool, again, in a manual process. How are you managing your supply chain? Someone's doing the component sourcing. Typically, that couldn't be a task that can take up a considerable amount of time. Oftentimes, you have additional bill of materials management, putting it into the format for purchasing or for release or for your suppliers to quote your assemblies. SOLIDWORKS PCB is an integrated flow. It has rapid and accurate synchronization, including the supply chain management portion. This integrated flow, rapid and accurate synchronization continues on and through to the final product. In the release process, you've got that whole set of board files, manufacturing files, fabrication files, assembly files, and you can detail all of your final drawings in SOLIDWORKS CAD. This provides a much higher level of consistency. You're using documentation templates. These templates are reusable. Therefore, it provides you the consistency for every product that you develop. So we talked about these design challenges at the beginning of the presentation. Our solution that you're going to see today provides consistent solutions, accurate solutions, error-reducing solutions. So for electromechanical, we have seamless collaboration. It's in a managed environment. We have a very unified platform with all of SOLIDWORKS products. SOLIDWORKS PCB is completely unified. Schematics, layout, supply chain management, and the seamless collaboration. You don't have inconsistencies of common vaults. You're using PCB services, giving you that version control on your PCB projects. You're using PDM for your overall data management of your final product assembly. You're now not wasting time doing these non-role specific tasks. You're leveraging SOLIDWORKS CAD drawings, SOLIDWORKS formats, SOLIDWORKS release process. So with the partnership of SOLIDWORKS and Hawkridge Systems, you can accelerate your product growth. Right? So let's look at the tools and how we can accomplish this design workflow. So here in SOLIDWORKS PCB, we have a 2-page schematic and a simple layout. We're going to be collaborating this layout into SOLIDWORKS, loading the assembly into a higher level assembly, looking at that collision detection, making modifications to components in SOLIDWORKS, and then have that instantaneously and automatically update our SOLIDWORKS PCB design file. I mentioned to you earlier about the supplier links. The supplier information is now embedded into the schematic symbols. So we can look at our supplier information real time. It's going out to the internet, it's looking at the supplier, it's giving you real information. Not only is the information accurate in real time, but all of the parametric data is also loaded to the component. So depending on the supplier you choose, the supplier part number, the availability, you can control all of the parametric data, and then this parametric data can be output in a format that best suits your suppliers, your assemblers, and people that deal with your outputs from your PCB tool. Again, we have this linked on multiple components and allowing us to look at real-time costing, real-time availability, links to the data sheet, right? We just go right there and we click on the PDF, we get the data sheet for this particular component. So again, everything is integrated into the tool. So let's talk about real-time collaboration now. We've got our PCB layout done. We want to get this into our mechanical assembly. We want to look at the functionality and the accuracy of our placement, and we can do that using SOLIDWORKS 3D CAD. SOLIDWORKS PCB contains the real-time collaboration through what we call the PCB connector. This connector is actually connecting to a standalone database. Let's take a look at that. So here's our standalone database. You can log into it through a web page, and you will see all of your project files, and the multiple times that you have committed your project to version control. So you can actually enter the database and retrieve previous saved project files. So when we open the connector panel, this connects us to the database, and we simply push and pull data to and from SOLIDWORKS PCB and SOLIDWORKS 3D CAD. So let's do that. Let's do the push. The information that gets pushed is all mechanical. Okay, so we're going to get a PCB board part. we're going to get a SOLIDWORKS part model for every single component that's on our PCB design. Okay? So now we're going to switch hats and we're going to become the mechanical engineer. So we open up SOLIDWORKS. Every SOLIDWORKS version available today from 2016, Service Pack 3, contains capability to do collaboration with SOLIDWORKS PCB or with Altium Designer if you purchase the SOLIDWORKS PCB connector. It's merely just a tools add-in selection. You scroll down and we have a SOLIDWORKS PCB selection. You activate that selection and it produces an additional icon onto your right-hand panel. By opening that icon, you also are now connected to that PCB services database. When connected to the database, we simply pull the project into SOLIDWORKS. By pulling board, we can see a list of multiple projects that are managed in the database, and we can select the project that we're working on today and create that SOLIDWORKS assembly. SOLIDWORKS always builds the assembly of the PCB. You can start brand new projects in SOLIDWORKS as well. Create a new project, create your board part definition, put in your cutouts, your mounting holes, and then you can send that to the database and have the PCB designer retrieve that PCB and begin the PCB layout project. Okay, so here we have our PCB assembly. We have all of our components as SOLIDWORKS parts listed in the assembly tree. This functionality now is no different than any other mechanical assembly that you have created in SOLIDWORKS. All of the functionality for part manipulation, modifications, movement is now all available on your PCB assembly. So let's take this assembly and load it into our final product assembly. I'm going to open up our higher level assembly, which already contains a previously collaborated PCB assembly. So we have a two-board assembly into a single chassis. Okay. So now let's add the assembly that we previously collaborated. Okay, we drop that in there. Now we want to reference this new assembly to features of our existing SOLIDWORKS assembly, which also has an existing PCB in it. We'll simply just make some mate references for some features on our existing assembly and our new assembly. Okay. Here we're just doing a simple concentric mate to line up the holes for the assembly. Okay. Now additionally, we need to set the offset height between the two boards. Right? We've lined them up in a position. Now we need to set the overall height. So we just pick the back of the board, and we need that to be positioned inside of the header on the secondary PCB. And we need to set that distance at 3.2 millimeters. Perfect. So now we have our two assemblies linked, referenced. These reference mates will continue to be maintained as you work through additional changes of this overall PCB assembly. and product assembly, right? So we've got these two components in there with our chassis and our case. So let's evaluate the interference detection. Do we have any collisions? SOLIDWORKS will calculate the components in the assembly and give us a detailed report showing error markers where we have that collision. It'll take a minute or so to run this. And then once it's completed, we'll evaluate the collision and then modify the component to clear that collision. All right, perfect. So now we can see we do in fact have connector collision between the RF connector and our case. Okay, easy manipulation. Okay, what we're going to do in order to clear that up is open the PCB assembly that we previously collaborated and make an adjustment to that component. So within our assembly tree, we'll go to the PCB Experience project and we'll edit that assembly. Okay. Once we're editing that assembly now, we're going to select this component and we're going to move that component with the triad feature and we're going to move it approximately 2.4 millimeters. Perfect. Go back to our assembly. And now we can clearly see that those connectors are 100% centered within the chassis. We can close the case, move on to completion of the documentation, release process of the files. However, we've made that change to that component, and you can see now that the new position of this component is actually interfering with some of the push button switches. This adjustment would now be corrected in SOLIDWORKS PCB, but we can absolutely incorporate this change from SOLIDWORKS into SOLIDWORKS PCB. So let's take a look at how we're going to do that. Okay, so we'll go back to our original assembly. Again, we've got that new position of the component. We're clearly colliding now with the dip switch or the push button switch. We'll get that back into PCB and we'll clean that up using our SOLIDWORKS PCB tool. Same process. Opening the connector panel attaches us to the database. Now we're pushing this new information back to SOLIDWORKS PCB. Put in a note for history and tracking. Opening SOLIDWORKS PCB, we still have the original placement. Connecting to the database gives you that real-time notification. Okay, we're not file exporting and importing. We're pushing and pulling real-time data. So let's view that change. What do we have? We did move H4. Beauty of SOLIDWORKS PCB, it's also a 3D visualization layout tool. So when I click on H4, that model is animated and moved to its new position. And I simply just accept that change. And then instantaneously, my circuit board design has been updated. Now we would go back to the 2D mode and we would correct the placement for the push button dip switches and the reroute the traces and then do that final release. And then as many times as we like, we can reincorporate and recollaborate back and forth between SOLIDWORKS and SOLIDWORKS PCB. We also mentioned in the presentation about documentation using SOLIDWORks. So going back to our assembly in SOLIDWORks, we'd simply just make a drawing. We'll use the B border. Again, this could be your company's default template for PCB documentation. Could include all your fabrication notes, your layer stack-ups, your material, your tolerances. All that information can be created directly in SOLIDWORks. So opening the panel, we can select one of the views, bring that onto our drawing, and then anywhere we pan, we're going to get isometric views, bottom views, side views. Okay, so let's drop a couple more views down here. All right, so now we have our drawing of our PCB board into a SOLIDWORks template. What else would we add? Let's add the bill of materials. So 2 clicks. Now we have our complete bill of materials for our assembly. We can also do many additional items: bubble drawings, assembly rework instructions, detailed technical information. Publish this to Visualize and Composer and other SOLIDWORks products. Right? So today we have demonstrated the solution items in our original design challenges, right? What did we have and what did we talk about in our original design challenges? No more disconnect. No lack of a modern design flow. We're using state-of-the-art single vendor product tools. We have consistency of our common database, so that's no hindrance at all to the release of the files. And then we definitely save time and reduce the potential errors caused by PCBs not fitting into mechanical enclosures. Okay, with that, I'd like to go ahead and open up the poll questions and let me know if anybody has any questions at all, and we'll go ahead and get those answered. How does this compare to using Altium with SOLIDWORks? Great question, Aaron. So the collaboration portion that I showed you is exactly the same between SOLIDWORks PCB and Altium Designer. So the modifications that I did in SOLIDWORks, the movement of the RF connector, the association of the collaborative PCB assembly to the overall product chassis with the additional PCB, that is no different between Altium and SOLIDWORks PCB. The collaboration portion is what is provided with the SOLIDWORks PCB standalone connector product that is exclusively for Altium Designer. That product license is tied to Altium Designer. The value of that is it allows a single Altium Designer to collaborate with multiple SOLIDWORks users, because we saw in SOLIDWORks it already contains the capability to connect to the database and to share data back and forth. What are the downsides to having all the components in the Altium database? There's no downside to having the components in Altium. The models that are derived in SOLIDWORks must come from your Altium footprint library. It'll work for any type of a product, consumer products, medical products, as long as you have that PC board design from Altium that contains 3D models onto your footprints. Those models will be collaborated. I mentioned as well, the information that is collaborated today is all mechanical. Your electrical integrity is not jeopardized, it's not disrupted. Now, if you happen to move a component that has routed traces, you will see a new guide wire or a rat's nest from the end of the route to the location of the new pin. Because electronic connectivity information is not shared, therefore it's not disrupted. Altium and SOLIDWORKS PCB maintain the connectivity through the integrated workflow of the schematic and the PCB. Those two items are always in synchronization because of the project structure inside of SOLIDWORKS PCB. You have your overall project, you have multiple schematic pages, including your libraries. You can sync your libraries right to your project. You can also sync your library database to your project. You do not have to have Altium and SOLIDWORKS on the same machine. Absolutely not. Now, in my demonstration today, of course, I have both applications installed. But if you have a mechanical user that's in a different building or in a different location, as long as you're on the same network and you can attach to that PCB services database, or in an instance where you may be using the Altium paid vault, you can use that vault for mechanical collaboration. So the application installation is not specific to anyone. So you worked for an ISO 1345. That's the medical spec company that maintained that they own the entire database on their server. Again, I think as long as if you're an Altium designer or SOLIDWORKS PCB user, as long as you can connect to their server, and if they want to maintain the PCB services database, you could certainly do that. The location of the PCB services database is completely up to the organization. It can live on a network server. It could live on someone else's network server, but you would just need to have direct accessibility to that server. Can you export a similar model from Altium? I rarely want that much info in my SOLIDWORKS file as it gets super slow. Can I export a dumb solid from SOLIDWORKS PCB or export a light assembly? The way to do that, you can actually create a variant in Altium and basically unstuff those models that you don't want to see. But I think you would find too that if you're currently using step files from Altium or some other methodology of exporting, those are going to be much heavier type assemblies in SOLIDWORKS because there's a lot more information. We've collaborated boards with, hundreds of parts, and the assemblies are lightweight. You can manipulate them around. They don't become processor hungry or anything like that. So I don't view that as an issue. It just really depends on the size of your board. But if there are components that you don't want to see, let's say you only want to see your critical connectors, then you could create that variant, and then SOLIDWORKS will create a secondary configuration that you can view, and you can work on that configuration instead of the overall master assembly that's got every single model installed. Cost of the products. Well, I'm certainly not the sales manager or the sales individual. I can give you the retail price, but certainly I would encourage you to reach out to your SOLIDWORKS account manager. We have a number of promotions, but MSRP for the SOLIDWORKS PCB connector, which again is exclusively for Altium, that product is $39.95 with a $9.95 yearly subscription. The SOLIDWORKS PCB product, which includes the collaboration and is going to give you full schematic capture, full library capability, full PCB layout, that is $59.95 with a $14.95 yearly subscription. Can you go over the exporting PCB as an assembly step again? Certainly. We've got time to do that. Let's just start from scratch again. We'll come back to questions if anybody has any, but let's go ahead and go back through that. How did we create that original assembly? Okay. All right. We could actually, I can collaborate another project if you like. Maybe we'll do that. Let's go ahead and do that. So let's just go to File, open a project. All right, so now what we're doing is we're going back into our database, right? These are all my managed projects. And let's look at this project. We'll open up the PCB document. Okay, I should get the parts on here too, so let's go ahead and do that. Now, this particular project does have that variant that I mentioned that will turn on and off the components. So we'll get a chance to look at that as well. So we have, you can see these non-fitted components. So I've purposely turned off the discrete capacitors because they're tiny, and typically in a mechanical environment, you're not really too concerned about really tiny discrete components. You're more interested in those critical components, the height of the components, maybe the large BGA IC component placement. Okay. So let me go ahead and get these parts onto the board. We're just going to throw them on real quick, and then we'll do that collaboration. Again, the process of the collaboration is the same regardless if the components are placed or not placed or they're 100% accurate. I can do all of that movement in SolidWorks. All right, so we've got these components. I'm just going to grab them and quickly throw them onto the PCB. This particular project also uses a chassis, and I use SolidWorks to create the board outline. I use SolidWorks to position the holes. I also use SolidWorks to change the diameter of the holes. When you change the diameter of a hole in SolidWorks, it automatically updates the drill value in SolidWorks PCB. Let me show you another feature that SolidWorks reads directly from SolidWorks PCB, and that's our layer stack up. Right? Every PCB's got a layer stack up definition. Whether you do it in the CAD tool or whether you do it in your documentation, you've got to tell your vendor, hey, how many layers of board do I have? What's my dielectric thicknesses? What kind of solder mask do I need? What's the thickness I expect? So in this particular project, we have a board thickness of 61.6 mils. SolidWorks will read that value directly, and it will create the extruded PCB board part at that thickness minus the value of the solder mask. Okay, so we would take 0.8 off of the 61.6 and we'd get a 60.8 mil SolidWorks PCB extruded part. Okay, so back to the collaboration. How do we create this assembly in SolidWorks? All right. We connect to our database. We push it out there. We tell our mechanical engineer that we've got a new PCB. Okay, everything's exported. Models, PCB. Now we can go pull that into SolidWorks. So let's close down many of these assemblies. I'm going to save them, and we'll close this guy. All right, so again, blank SolidWorks session, connector panels invoked, we go to the database, we pull board. The project we're working on now is a library test project, and we're going to put that into our SolidWorks assembly folder. So SolidWorks will always ask you, hey, where do you want to save this assembly that I'm about to create? And you can choose. You can save that assembly directly in PDM. The beauty of that is it also puts the models in there for you. Okay? So again, the process is build the board part, recreate the models as SOLIDWORKS parts, and then position them according to our layout from PCB. Right? Then what I would do is I would then insert a component into this assembly. Okay, so let's do that. I'll show you the chassis that goes with this guy. So we go to our parts folder, and we have our chassis. Okay, and again, you can see that they're not referenced. Definitely the board part is not the right size. So I would use SOLIDWORKS to make these modifications. Reference the two items together and position the components and the mounting holes onto the standoffs. Again, that's done simply by just creating a simple mate. So we take the back of the board and we can put that right on that surface. Okay. So now I've got my chassis in my assembly, and it's now referenced correctly. If I position this close proximity, that's close. Just to do a couple things here. So most of the components are in there. Let's go ahead and go to this hole. All the holes in the board will be listed under the board part itself. So we're going to go to, we're going to edit that. Okay, so now we've got that on the cursor. We could drop that onto a wireframe view. Now, again, beauty of SOLIDWORKS, what do we get? We get automatic snap right to the center of the hole. So now we've positioned that mounting hole in its proper location, right? All right, let's do that with, before we do that, we've got a capacitor in the way here. So let's go ahead and just move that guy real quick. See how I can grab the models and just move them around anywhere? And the current version of the collaboration provides a dynamic mate for the components on the top surface or the bottom surface at which they were originally placed in the PCB design tool. However, I know I can move models all day long in SOLIDWORKS from the top of the board to the bottom of the board. That will not correspond back to the PCB layout. The PCB layout controls the surface placement. So if you need or have parts on the back, you would put them on the back first in SOLIDWORKS PCB or Altium Designer. So this one we're going to grab. Okay, and go back to the wireframe, grab this hole, and drop him on there, right? So as a last step, we're pretty close now. Let's go ahead and adjust the board real quick, and then we'll push that back to PCB. How would I do that? Let's take a look real quick. All right, we'll rebuild. We'll save that guy. All right, so now we got a board. We got a board, and we got the components, and we've got our chassis. But obviously, our PCB is way too big, right? So I'll show you how we quickly and accurately fix that in SOLIDWORKS, so that we can then push that back to SOLIDWORKS PCB. Okay, we just click on the board part, and we're going to edit the sketch for that part. Now, using typical SOLIDWORKS sketch tools, I'm free to do whatever I want. Dimension it, slide them, get rid of them. All right, so let's get rid of them. We'll get rid of that outline. And then we're going to select the back of the chassis before it starts the bend. Okay, so we take that, and you just convert that to the board part, right? So in 3 clicks, I now have a PCB that's perfectly fit to my chassis. I move the mounting holes. I can move components all day long, right? So again, if I position this over here, SOLIDWORKS recalculates the hole position and repositions the holes as part of the board part. So it does differentiate between the model and the holes that are associated with the through-hole component. As in SOLIDWORKS PCB or Altium, that's going to be all combined into one, right? That's part of your footprint. Where SOLIDWORKS being a 3D mechanical tool, it needs to separate mechanical features from SOLIDWORKS part models. But when we drop the component, SOLIDWORKS will recreate the holes in the board part at their new position. All right, so we moved a couple parts. Let's go ahead and grab this one. All right, now process the same, back to PCB. There's our notification, and here's all of the history that we've been working on this project clear back in last year. So you do not lose your history as long as you maintain the project names between SOLIDWORKS PCB and SOLIDWORKS. So let's push this. What we do, we adjusted the PCB and the mounting holes. Doing a post pushes all that information back to PCB Services database. We close SOLIDWORKS, go back to our PCB design, opening the panel. There's our notification. Now we should see multiple changes on this design. And there we have a lot of changes. We changed the board, we moved several components. Oh, and now look, we're also getting the chassis. Nice. So you have the ability now to bring parts back from SOLIDWORKS into SOLIDWORKS PCB. So if you want to look at animation, right, there's what's happening with our board outline. And then here's the new position of the mounting holes. See how they quickly go there? So anything you want to look at, you click on it, and this gives you the ability to reject or accept the changes. So everything is not all or nothing. Both in SOLIDWORKS and in SOLIDWORKS PCB, you can pick and choose what you like to accept. We're just going to go ahead and select everything except the chassis. I'm not going to bring the chassis into my PCB right now. So we'll turn that off. Instantaneously updated, real time from SOLIDWORKS. We go to the 3D view, and that's essentially the assembly we created in SOLIDWORKS. Let's go back to our poll questions and see if anybody has any additional questions. We wrap up. Would it be easy to add a keep out for the chassis part to the board? Let's talk about more of a placement barrier. I wouldn't necessarily call it a keep out. What you would do in SOLIDWORKS is you could create an extrusion, give it a 0 height. You could create the size of that extrusion. You could place that extrusion onto the board surface itself, and then anytime you moved a component with a model into that area in PCB, you would get a collision. The other thing you can do is, let's say you have height restricted area, where maybe only components that are less than 120 mils can go into a particular area of your PCB. I can define that area in SOLIDWORKS using the same create extrusion process, but now I would set the offset of that extrusion to be 120 mils off the surface of the PCB. So anytime I move a model under the extrusion in PCB, it's not going to collide if it's less than 120 mils. If it's taller than 120, then you're going to get that collision in PCB during placement. You would see that DRC and you would know, hey, I can't have that component there because it's taller than 120 mils. So we refer to them as placement barriers because you're using collision tools to detect that, not necessarily a keep out like you would create a keep out in Altium or SOLIDWORKS PCB, but the functionality from a placement standpoint is the same. Any other questions? I think we're really good on time today, wrapping up just before noon Pacific time. I hope everyone found this Wednesday webinar useful, informative, and please, if you have any additional questions, do not hesitate to reach out to your SOLIDWORKS account manager, and we can further explore other aspects of the tools or additional information that your organization might be seeking. Again, I do appreciate everyone's time and hope to see you soon. Thank you very much. And with that, we're going to go ahead and conclude today's Wednesday webinar on how to reduce respin costs for PCBs.